Good evening, all. Today I will be discussing the summary lecture for the course Pericyclic Reactions and Organic Photochemistry. Right now, I will share the slides. Hope second. Hope the slides are visible. So, good evening, everyone. Today I will be conducting the summary tutorials for NPTEL PMRF tutorial session of the course Pericyclic Reactions and Organic Photochemistry by Professor S. Shangaraman from IIT Madras. Myself, Anisha Suresh, PMRF TA for this course from IIT Bombay. So, in this lecture, we will be discussing various questions which have appeared for the IIT JAM, CSIR, NET, etc. from this pericyclic reactions and organic photochemistry. So, coming to the first question, what is a major product formed in the following reaction? So, here is cyclopentadiene and a alkene which is substituted by methyl ester is given. So, it is subjected to heating condition. So, 4 plus 2 cycloaddition under heating condition. It is 4 plus 2 cycloaddition is thermally allowed, and what will be the product that will be forming? So, we know that this is the 4 pi component and this is the 2 pi component. So since two ester groups are attached, this will be electron deficient dienophile, and this is the diene. So we can write like this is the diene and this is the dienophile. And we know that for 4 plus 2 cycloaddition, that is Diels-Alder reaction, it follows the endo rule. That is, these ester groups come from below the plane, so as to ensure that secondary interactions are taking place. So what will be the product that is formed? We can see the reaction. So this is our diene, that is cyclopentadiene, and this is our dienophile. So it is approaching from below the plane. So this will be the mechanism that is taking place. Then, one second. So here a new double bond is formed, and these two methyl groups will come from below the plane, CO2 Me, CO2 Me, and the hydrogens will be coming above the plane. So when we will be looking at the options that is given, the option that corresponds to the answer we got is option C. So the right option is option C. I hope the mechanism is clear. So here the main thing is endo rule, that is the dienophile will be approaching from below the plane, so that this CO2 CH3 groups, that CO2 carbonyl groups will be having secondary interactions with the orbitals of the diene. Now coming to the next question, the following conversion is an example of. Here the starting material is given, it is subjected for heating condition, and this is the product that is forming. So the question is, this following conversion is an example of, and some name reactions have been given: oxycop rearrangement, sigmatropic rearrangement, Claisen rearrangement, and pericyclic reaction. So we will see what is the reaction that is taking place here. So this is our starting material. So we can number it like 3, 2, 1, 3, 2, 1. So we will be getting Me, Me, double bond, double bond O, which is this product. It is one CH2. One second. CH2, CH2. Two CH2s will be there. Sorry for the mistake. This double bond will be coming here. Then here a CH2 will be there. This will also be a CH2. This will also be a CH2. 1, 2. And this will be the carbonyl group. So this is the product that is formed. So this is a 3,3 sigmatropic rearrangement, which is also known as Claisen rearrangement, as it is involving an oxygen in the system. And these sigmatropic rearrangements are an example of pericyclic reactions. So from the options that is given, the right options will be, it is a sigmatropic rearrangement, it is also known as Claisen rearrangement, and it is an example of pericyclic reaction. Okay, oxycop rearrangement is known as Claisen rearrangement. So this is a MSQ type of question that came in JAM 2017. So the right options will be option B, C, and D. Now coming to the third question. So here the Jablonski diagram is given. I hope the Jablonski diagram is clear to everyone, as you have seen the organic photochemistry lectures. So in the Jablonski diagram given below, the initial excitation take place from the singlet ground state to the second singlet excited state, that is S0 to S2. As we can see here, this is the absorption that is taking place from the S0 of uh, from the S, that is singlet ground state, it is getting excited to the second singlet excited state. Now they have shown some processes. Match the processes to the events marked as A, B, and C. So we know that from S2 by non-radiative pathway it is coming to S1. So we know that this is internal conversion, as we have seen the Jablonski diagram previously. Then from S1 it is going to T2. So it is given A, and from T2 it is going to T1, it is given B, and from B it is, that is from T1 it is going to S0, it is given C. So we have to identify what is A, B, and C. So coming to the Jablonski diagram, so here we can see this is absorption. When it is irradiated with light from the S0, that is ground state, it is getting excited to the other excited singlet states. So it is absorption. So from the excited singlet states, when it is coming to the lower excited states without that is non-radiative pathway, it is known as internal conversion. Okay, when it is coming to like S1 to S0, or from T1 to T2 to T1, etc., by means of radiative pathway, it is known as fluorescence. And when is coming when it is crossing, that is S1 to T1 by non-radiative pathway, it is known as intersystem crossing. And when it is coming from the triplet state to the excited triplet state to the ground singlet state, it is known as phosphorescence. So from the information that is given in the Jablonski diagram that we are seeing right now, we can say this A, that is S1 to T2 non-radiative pathway, is known as intersystem crossing. Intersystem crossing. in the system crossing. Then T2 to T1 radiative loss. It is known as fluorescence because there is no change in um, like there is no change from triplet to singlet. So it is known as fluorescence. And here from triplet to singlet radiative loss is known as phosphorescence. So the right option will be A, intersystem crossing, B, fluorescence, and C, phosphorescence. Option D is the right answer. I hope it is clear. From the Jablonski diagram, you can get between fluorescence and phosphorescence. Fluorescence will be taking place. It is a radiative pathway by which, without changing the changing from triplet to singlet state, if radiative pathway is taking place, that is either from singlet to singlet or triplet to triplet, radiative loss of energy, it is known as fluorescence. And if it is taking place from a triplet to singlet state, it is known as phosphorescence. As it since it is spin forbidden, it will be taking more time. That is why phosphorescence take place with more time than that of fluorescence. I hope this is clear. Now coming to question number 4. The mechanisms for the formation of molecules A and B involved respectively. So we have so this is the starting material. Here when it is taking place under normal photochemical condition without the use of any sensitizers, it is giving product B. And if we are using any sensitizer like triplet sensitizer, it gives the product A. So we are asked what is the mechanism that these reactions are going through, and some of the options are given like A, oxidipymethane rearrangement and Norrish type 2 cleavage, Norrish type 1 cleavage and oxidipymethane rearrangement. Then option C, oxidipymethane rearrangement and Norrish type 1 cleavage. Option D, Norrish type 1 cleavage and Norrish type 2 cleavage. So it is A and B respectively, okay? So we will see what is the mechanism it is going through. This was discussed in the lecture. So here this is our starting material. When we are irradiating it directly, so this is our starting material. When we are subjecting it for direct irradiation, it will give this product, that is B. Direct irradiation, it is giving the product B. And when we are using a triplet sensitizer, it will give the product A. So here this is clear, okay? So what is taking place here? Evidence for involvement of singlet N pi star state in alpha fragmentation and triplet pi star state in 1,2 rearrangement. Here a 1,2 rearrangement is taking place, that is oxa dipymethane rearrangement. Okay, here an oxa dipymethane rearrangement is taking place, whereas here first an alpha fragmentation will be taking place and then it will recombine, giving this cyclobutanone. And here this radical will rearrange and this double bond, here a new here the radical that will be formed after recombination will be quenched. So this is a Norrish type 1 reaction and this is oxidipymethane rearrangement. Since it is alpha fragmentation taking place, it is a Norrish type 1 reaction. If you want to see the mechanism, it will be like here alpha fragmentation will take place. You will get this is a triplet radical, tertiary radical. Then it will undergo recombination here and this will get quenched. So we will get 1, 2, 3, 4. This is the cyclobutadiene that will be formed. And here this will be the product formed after alpha fragmentation. Now if we consider oxidipymethane rearrangement, upon irradiation we will get these two radicals. Now radical recombination will be taking place. These two radicals will combine, these two radicals will combine, then they will break and then they will recombine giving this system. Okay, tertiary radical will be forming while breaking. Now this will break. So we can write like here a, and now here a tertiary radical have formed O dot. So this will combine giving a ketone and this will combine giving this bridged system. Okay, I hope the mechanism is clear. So the right option is option C, that is oxidipymethane rearrangement and Norrish type 1 cleavage. Now coming to the next question, question number 5. The given reaction proceeds via. So this is our starting materials. Upon heating, it will give this product. So first what have taken place and next what will be taking place. So options are like first 1 3 hydrogen shift followed by 4 plus 2 cycloaddition, 1 5 hydrogen shift followed by 4 plus 2 cycloaddition, a 3 plus 2 cycloaddition followed by hydrate shift, 4 plus 2 cycloaddition followed by alkyl shift. So we can see the mechanism. So here the hydrogen that is here 1, 2, 3, 4, 5. It will shift to here and we will get a system like this. Okay, a system like this will be formed that will undergo 4 plus 2 cycloaddition with this dienophile giving the product. So here, since endo addition will be taking place, these carbonyl groups will be coming from below the plane. That is why the hydrogen is represented above the plane. So the first step that is taking place is 1,5 hydrogen shift and then a 4 plus 2 cycloaddition reaction giving the desired product. So option B is the right answer. Okay, any doubts? Now coming to question number 6. So this type of question was also discussed in the lectures. So the following transformation is an example of. So this is a question that came in CSIR net June 2021. So is it an example of 3 pi 2 pi cycloaddition, a 6 pi 2 pi cycloaddition, 8 pi 2 pi cycloaddition, or 8 pi 4 pi cycloaddition? So let us see. So this is a 1, 2, 3, 4. So this is a 8 pi system and this is a 2 pi system. Okay, so we are having this system and it is reacting with this benzene. So what will be happening? This will attack over here. It will come and attack here. This bond will shift. This bond will shift here. This bond will shift here. And we will get this product. So it is an example of 8 pi 2 pi cycloaddition. So higher cycloaddition reactions we have seen. So this is an example of such a cycloaddition reaction. Okay. Now coming to the next question. The following reaction proceeds through A. So it is a question from CSIR net December 2013. So what sort of reaction is taking place here? So we can see, we can number it like 3, 2, 1, 3, 2, 1. Okay, so a 3, 3 sigmatropic rearrangement is taking place over here. So this will go and attack here, this will shift here, this bond will break. Okay, so what is happening? If we number it like 1, 2, 3, 4, 5, 6, a bond is forming between 1 and 6. 1 and 6, new bond formed. 5 and 6, it becomes a single bond. 4 and 5, it becomes a double bond. 7, 8. 4 and 7, no change. 7 and 8, no change. Okay. And on, so here 1, 2, 3, 4, 7, 8. Sorry. 1, 1, 6, 5, 4, 7, 8. On 5 there is a methyl group, and on 4 there is a, this bond is broken. Okay. And in 1, 1, 2, and 3. So here it will be CH2. Okay. It is not oxygen. This is a CH2, not oxygen. So it will be a 3,3 sigmatropic rearrangement. So once we will do the numbering, it will be easy for us to follow the pathway. So this, if we draw like 5, 4, 7, 8, 1, 6. So here CHO will be coming, and here methyl will be coming. That is our given product. So it is a 3,3 sigmatropic rearrangement that is taking place here. Is it clear? Option C, that is a 3,3 sigmatropic rearrangement. Now this is question number 8. According to Frontier molecular orbital FMO theory, the highest occupied molecular orbital HOMO of hexatriene in the following reaction is. So here hexatriene is given and it is photochemical condition. Under photochemical condition, Psi4 is the highest occupied molecular orbital of hexatriene. So we can see 1, 2, 3, 1, 2, 3, 4, 5, 6. So there will be hexatriene means 6 electrons. So it will be coming in 3 pairs. So it will be psi 1, 2 electron, psi 2, 2 electron, psi 3, 2 electrons. When it is subjected to H nu, then it will be psi 1, 2 electrons, psi 2, 2 electrons, psi 3, 1 electron, and psi 4, 1 electron. So psi 4 will be the HOMO. Psi 4 will be having 3 nodes. So here 1, 2, and 3. So we can write it like here 1 node. Okay. Next node will be here. And the next node will be here. So this is the psi 4 orbital, which is HOMO of cyclohexatriene, under each new condition. So here this is having 1, 2, 2 nodes. So this is node the product. This is having one node. This is node the desired product. This is having two nodes. This is also node the product. Here as we have seen, this is having three nodes. So option 4 will be the right answer. Okay. Now coming to the next question. So here the major product obtained in the following reaction is. So this is the diene and this is the dienophile. So here the diene electron releasing group. So this will be the electron rich sender, and here this is also an electron releasing group. So this will be electron rich sender and this will be the electron deficient sender. Okay, so the reaction will be taking place with this regiochemistry. I will show you. So this is the electron deficient sender, this is the electron rich sender. They will react, and what will be the product that you will get. Okay, so I will write in the next page. Here NH2 OCH3. So this is the electron rich sender. Here this is the electron rich sender and this is the electron deficient sender. So this will attack here, this will attack here, and this is the product that you will get. So correct option is option A. Option A will be the right answer. Okay. Now coming to the next question. The diene and the dienophiles that can be employed to synthesize Norborna diene iso are. So they have given four options. So this when it is reacting with ethyne, you will be getting, one second, sorry, Norborna diene. Second option, if you are reacting like with this, you will get norbornene, not diene. And when you are reacting with this, you will get a pen, cyclohexene. And if you are reacting this, you will get a cyclohexene substituted with two methyl groups. So the right option will be option number A. Okay, so you are having a cyclohexadiene and an alkene, that is ethene. So if you are reacting, you will get Norborna diene. This was a quite easy question. Based on the products, you can go back to the By solving the products, you can go back to the answer and you will get the right answer. Now coming to question number 11. The major product formed in the following reaction is. So this is an example of 3, 2, 1, 3, 2, 1, 3, 3 sigmatropic rearrangement, that is Claisen rearrangement. So we will see the mechanism. You will get. So the stereochemistry of hydrogen will not matter now because a double bond have formed there. OH double bond, and here a double bond have formed. So this will undergo ketoenol tautomerism. So here a ketone will be forming and here a double bond will be there. This is the final product of 3,3 sigmatropic rearrangement. Clear? So the right option will be option 3. Hmm? Now coming to the question number 12. The final product formed in the following reaction is. So here as you can see, diene is there, a dienophile is there, a 4 plus 2 cycloaddition reaction can take place. Okay. So here this will go attack here, this bond will come here and a double bond will be forming here. So you will get CO2ET, CO2ET, CN double bond. Since if a kilotropic elimination can take place, it will give the aromaticity for this system. A elimination reaction will take place. So it will be in this fashion, minus ethene. It will give an aromatic system. CN, CO2ET, CO2ET. So what is the reactions that are taking place here? A 4 plus 2 cycloaddition followed by kilotropic elimination. So the right answer will be option A. So I have discussed few important questions from the pericyclic reactions and organic photochemistry part. So I hope this video will be helpful for you who are preparing for the exams. Thank you so much. Thank you so much for attending the course and attending my tutorials. Once again, thank you. So if you are having any doubts, you can post it in the comment section of the video that I will be uploading. Thank you.